We will be asked to graph linear equations. And there are several methods that we could use to graph. You can use them all at any time, depending on what you're comfortable with. One option is to make an input-output table. Find some ordered pairs that will make this equation true. So I like to put in positive and negative numbers to see what the pattern will look like on the graph. So if x equals -2, that means -2 plus 2 times y is going to equal 4. If I solve this for y, that means 2 times y is going to equal 6, so y would be 3. So when x is -2, the y has to be 3. So that means the point -2 on the x, 3 on the y, is on this line. I'm going to follow that same process for another input. Let's say x is -1. If x is -1, y would have to be 2.5. When x is -1, y is 2.5. When x is 0, if you put a 0 in for x, the y would be 2. I can already see what the pattern's going to be. Since this is linear, it's a linear equation written in standard form. If I put a 1 in, y is going to be 1.5. And if I put a 2 in for x, the y would be 1. So I can plot the points 1, 1.5, 1, 1.5, 2, 1. Once I've established some order pairs, I can use a ruler to draw a line connecting all possible values of x and y that make this true. And then I can extend this concept with arrows to show that the number of solutions, the number of ordered pairs that make this true, are infinite. Another method you can use to graph a linear equation, if your equation is written in slope-intercept form, what you can do is the very first step, plot the point that is the y-intercept, 0, -4 in this case. And then from that point, use the rise over run idea for slope. So from your starting point or y-intercept, you can rise 2 and run 3. And that would find another point on your line. And then from that new point, you could rise 2, run 3. Now, rising up and running to the right is what we do when both numbers are positive. That is actually equivalent to making both rise and run negative. And what I mean by that is, if I go back to my starting point and I rise a -2, which means go down 2, and then I run a -3, which means to the left 3, you can see down 2 to the left 3 continues this pattern. So this is another strategy you can use to graph linear equations. And I find this comes in handy if your equation is written in slope-intercept form. For the very first example I showed, we said the equation was x plus 2y equals 4. This is written in standard form. You could rewrite it in slope-intercept form. And then you could make a table from slope-intercept form, or you could use our strategy of plotting the point, first point at our intercept, y-intercept, and then following rise over run, rise negative, so down 1 to the right 2, down 1 to the right 2. That shows us the pattern of this linear equation, and we can connect the points and extend that line and put arrows. And then what you can do, see, it doesn't matter if you use slope-intercept form or if you keep it in standard form and put your input-output table, they're the same line. So the form in which the equation is written doesn't matter. There is another strategy you can use if your equation is written in standard form. I'm going to use the same equation that we started with. What you can do is you can find the intercepts kind of easily when an equation is written in standard form. If you substitute 0 for x, that will give you the y-intercept. So if x is 0, 0 plus 2 times y equals 4. Y is going to have to be 2 in order to make this equation true. So we just found the y-intercept, and we can plot that point. The next thing I'm going to do is substitute 0 for y. So I'm going to go down here, and I'm going to rewrite the equation x plus 2 times 0 equals 4. 2 times 0 is 0. So your x-intercept is 4. So now I can plot 4, 0 as my x-intercept. And these 2 points determine the line. So we can connect the x with the y-intercept and extend the line and add arrows to show that the pattern continues. So we are asked to graph this equation. I notice it's written in standard form. So my first reaction is to come up with the y and x-intercepts and then graph those 2 points to make the line. When x is 0, -4 times y has to equal 12. If I divide both sides by -4, y equals -3. So there's the y-intercept. Now if I substitute 0 in for y, that means 3 times x must equal 12. Divide both sides by 3, x equals 4. So there's my x-intercept. So I can plot the x-intercept, the y-intercept, connect those 2 points, just graph the line for that linear equation. Okay, now I'm going to graph this linear equation, but I notice it's not written in slope-intercept, nor is it written in standard form. So I want to have the y alone so that this can be written in slope-intercept form. So I'm going to add 3 to both sides of the equation. Y equals 2x minus 4. So now that I have this written in slope-intercept form, the slope is 2 over 1, rise over run, and the y-intercept is -4. So I'm going to plot my starting point at -4 on the y-axis. And then from there, I'm going to rise 2 and run 1. Rise 2 and run 1. Or I could go down 2 and to the left 1. Down 2 and to the left 1. And the pattern would stay true. By plotting the y-intercept and then using rise over run, I've just graphed the line for this equation. Y equals the opposite of x plus 5. I'm going to graph this line determined by the equation by making an input-output table. I like to put negative numbers. I like to include when the input's 0, and I like to include positive numbers. It's an obvious linear pattern. And now when we connect and extend, and draw arrows, we've graphed all the solutions of that equation.